Yes, the magic timer has started, which means we're live. So let's make a start in. So this is Managing Complexity with Ktor. My name is Garth Gilmour. I'm a developer advocate at JetBrains, working an awful lot with the Ktor team, which hopefully qualifies me to give this talk. We'll find out by the end. Oops, where's my clicker? Yay, there we are. So Ktor is a really awesome framework for asynchronous client and server applications. It is Kodein approved, yeah? So must be, says so on the website. But there are an awful lot of great frameworks out there. So I'm feeling slightly intimidated, yeah? Because the creators and maintainers of HTTP for K have chosen to sit right in front of me here in a very intimidating manner and handed me a sticker right at the beginning of this talk, you know? So there are an awful lot of great frameworks in there, including but not limited to HTTP for K. So what then makes Ktor different? You know, so the purpose of this talk is just to give you the argument, yeah, for why you might want to give Ktor a try if you're not using it already. So we would say there's two things. First of all, our core values, and secondly, the shiny things. So I bet that you're all here for the shiny. So we're going to focus on the shiny, but let's just take a minute or two at the start to sum up what the core values are, because these core values drive the design and the implementation of all the different features that we're going to be looking at. Yeah. So in the Ktor team, the idea is to keep Ktor minimalist, flexible, simple, fast, okay? And to avoid boilerplate, both in the implementation and in the code that you write. So avoid boilerplate, avoid duplication, and avoid any form of magic, yeah? So if you talk to us at the booth, one of the things that we'll keep saying is no magic, yeah? So if you're a wizard, you don't get into the Ktor team. No wizards allowed. So in many ways, the Ktor philosophy is the antithesis, you know, the reverse of convention over configuration. So the framework never does more than you ask it to do. So for example, just including a jar on the class path, that doesn't automatically trigger any kind of functionality at all. So this doesn't mean that convention over configuration is wrong. That's another way of climbing the mountain. I like this metaphor here, which I have blatantly stolen, citation at the bottom, that developing with convention over configuration is like baking a cake with cake mix or pre-made icing or something like that. And you can make a great nutritious cake, but somebody comes up to you and says, I'm allergic to almonds. Are there any ground almonds in the mix? And you go, not sure, you know, let me look at the ingredients and so on, yeah? So eventually, you have to learn what the conventions were. Eventually, we all have to understand how the implementation is working. So I remember many years ago, I was doing JEE, or actually J2EE, and I was wiring 4 frameworks together using convention over configuration, and I thought I was using a particular distributed transactions manager. And then a couple of days in, I realized I couldn't be using that distributed transactions manager, or a day later, a distributed transactions manager, or a week later, a transactions manager. And then I started getting very worried about the safety of my code, yeah? So convention over configuration is one way to climb the mountain, but eventually we all have to learn what the rules are. So the Ktor folks really want to ensure that both they and you understand exactly what's going on. So if you don't install some functionality, if you don't ask for the functionality, it's not there. And that's the guiding principle. So that's going to inform all the shiny things that I'm about to show you. So I'm going to map out a very simple case study. And then to that case study, we're adding testing. We're adding DI with Koin. We're adding GraphQL. WebSockets. We'll do native execution, open telemetry, and finally fine-grained control. So we'll be running through all of these at high speed. Good news. Anybody jet lagged? Anybody a little bit overwarmed today? Anybody just tired because it's it's the second day of the conference? Yeah. so all of these shiny things will be starting from the same base, starting from the same foundation. So if your attention does wander, don't worry, we'll be doing a reset, after each of these mini demos. So the original idea was that I was going to live code all of this, but it's just too much shiny. Yeah. So we were discussing this with the Ktor team, and more shiny got added in. But there are sample projects for absolutely everything I'm about to show you. So in just a second, I'll put up the repo. And also, I have these nice, short, simple projects. The standard examples go into a lot more detail. So in the official samples, you can find lots more depth. So here's my repo here, which you can go out and play with immediately after the talk. And here's the link for the Ktor sample application. So I really recommend the second one especially. Those are well worth your time. So what's our case study going to be? Well, I'm sure everybody here has seen a superhero movie. And in a superhero movie, there's always the point where the hero or heroine needs to do deep research on a suspect. And they have this magic application where they print in their details and get back the life history of the person of interest. Yeah, and there are no ethical problems because you're a superhero. Yay, okay? So for the next 45 minutes, assume that you're a superhero, and we need to write an application like this. You can be any superhero you like, but because I'm at the one at the front, I'm Batman. Okay, so I get to be Batman. So we'll start out by saying that we want a history of all the Stack Overflow questions that anybody has ever asked. So we want to go out to Stack Overflow and find out the questions that this individual has asked. Dead simple. We can just go to this URL here, and you can see the two parameters that we need to pass in. We need to pass in the user ID and the name of the site, which is always going to be Stack Overflow. Where's my clicker? Yay, yeah. So for ethical reasons, I'll pick on me. I'll just always use my own ID. So that's my ID, and this is the JSON data structure that we get back. So we discover that in my 25 years in the industry, I've asked a grand total of 9 questions in Stack Overflow, which may mean I'm very smart. It may mean I'm very lazy, probably the second of those, but never mind. This is what an individual question is going to look like. So this is the details that we're going to get back from Stack Overflow. And from that data, we just want to magpie out 2 things. So we want to get the title of the question, and we want to get the ID. Those are the only 2 things that we're concerned with. So really great way to get started would be just to prototype this with Kotlin Notebook, because before we get into creating Ktor services and that kind of thing, we want to just make sure that we can use the HTTP client that Ktor gives us to go out and retrieve details about the questions. So Notebook is a great way to do this. Came in at last year's Kotlin Conf, and whenever we're talking about Ktor client, there are 3 really useful things. Number 1, at the top of the notebook, you can say use Ktor client. And that avoids a huge amount of mucking around with who likes Gradle? Yep. Who likes Maven? Yeah, so this avoids a huge amount of mucking around with build files, okay? And then in the case of notebooks, we're doing rapid prototyping. A little bit of magic is acceptable. Yeah, so in notebooks, you get this notebook HTTP client, which comes pre-configured with all the plugins that you're going to want for your rapid prototyping. So that's like an enhanced, a souped-up version of the standard HTTP client. And in particular, there's this magical method called deserialize JSON. So what that does is that gets the response and loads the response into anonymous types. So it looks at the structure of the JSON and creates Kotlin types on the fly to represent what it finds. So that means that you have a strongly typed way of accessing the data. So this is actually all we need here. So we can say use Ktor client at the top. And then underneath, we can use this built-in enhanced HTTP client, and we can give it our root URL. And then we can declare a bunch of variables, go out and send the request, and on the response that comes back, we can say deserialize the JSON. So that enables us to just dig into the data directly in a strongly typed way. And that's what I'm doing in the last 2 lines there. You can see him say data.items.map and then it.title. So I can just go and grab the data and then that gets printed. Woohoo. So if you're interested in notebooks, really good summary, really good in-depth tutorial. But that's us done with notebooks for this talk. So having proved that it works, we now want to go out and build a Stack Exchange client that we can put inside a Ktor service. So there's going to be 4 stages to this, as illustrated by the little boxes up there in the top right. So the first stage is easy, create a question type. And then create this Stack Exchange client. So how's that going to work? Well, that's going to wrap up the Ktor HTTP client. So whenever we ask the Stack Exchange client to do something, it's going to use the HTTP client. That's stage A. And then stage B, we'll go out and fetch the data from Stack Overflow. Stage C, we'll take from the data that we got back all the IDs and titles, and then we'll put those into a list of questions. Okay, so that's what we want our Stack Exchange client to do. And then to access this as an endpoint in its own right, we'll use this client in a root, and then we'll embed that root in a server. So this is our process for creating the Ktor service. So stage 1, we need a question type. Yay. Only hard thing there, we need to remember to annotate it with Kotlin X serialization. So we get the marshalling to and from JSON. Then we'll go out and create our Stack Exchange client. Whoops, sorry. Clicker. And then inside there, we're going to have an HTTP client. And we're going to need to configure that. I didn't realize this when I started the demo, but the information that you get back from Stack Overflow is zipped up. So remember, there's no magic. Yeah, it won't get unzipped by default, but I can go to the HTTP client and install the content encoding plugin and add support for unzipping what comes back from the server. And then having done that, I can write this function called fetch raw data, which does what it says in the tin. It goes out and sends a request and returns the response. And then from the response, I can magpie out the data. So I'll go here, and I'll get back the response. If the status isn't okay, we'll return an empty list. Otherwise, we'll get out the data. So remember, inside the response, we're going to have items, and the value of items is going to be an array of tables, and each table is going to have a question ID and a question title. So the way that we're going to pull that out is using the data frame library. So the data frame library is another marvelous library I would commend to you. So it takes data, CSV, JSON, whatever it happens to be, and it represents it as a set of nested tables. And it gives you these strongly typed accessor functions. So this is them here, okay? So if I say items, I'll get back all the items. There's only one, so I say first. And then for each thing inside items, well, I want the question ID and the question title. So how did I get these strongly typed accessor functions? Just like this. So I can say items is an accessor function, and it's going to return data frame, and then question ID and question title, well, they're going to be a column of long and a column of strings. So I'll be able to retrieve longs and strings. So data frame library is a really great way of accessing JSON data or CSV data or whatever in a strongly typed way and quickly accessing what you need. This talk got moved. I was going to say, please go to this talk. This talk has already happened. Yeah, but by the magic of the live stream, you can go back and watch it, and they'll be published on YouTube and so on. So I really commend this talk here for details of how data frames actually work. Right, so having done that, I can now write the standard configure serialization function, and I'll pass in an HTTP client engine. This is the low-level thing that the HTTP client uses to actually send the requests and get back the responses. And then having done that, I can write my route. So I'm going to have a single route, fetch questions, and then the user ID. That's going to respond to GET requests. And then we'll lift out the user ID. And if that isn't correct, then we'll return an error. Otherwise, what will we do? Well, we'll create our Stack Exchange client, and we'll ask the client to fetch the questions and then write those questions back to the client. If anything goes wrong, so let's say the user ID that we get is Fred. Well, we're expecting it to be a long. So if it's Fred, we'll get a number format exception, and again, we'll write the error down to the client. So the final stage of the process is just to take what we've done and embed that inside a server. So we'll use the default, Netty running on port 8080, and the CIO implementation of the HTTP client engine, that's the one we're going to use. So if you put that all together, you get a Ktor service, and you can start it running. And here's the endpoint here with my Stack Overflow ID, and it successfully returns the list of questions. So this is our foundation. This is our baseline. So for those of you who don't know Ktor, that's how to write a Ktor service and how to use the Ktor HTTP client. For everybody else, I apologize for delaying the shiny train. You know, let's now bring on the shiny. So these are the stages that we work through here. Excellent. So that's all now up and running. Let's show you all the shiny features. By the way, I asked Ali, can I have Cody looking at in amazement at a big shiny ball of wonderfulness? And it says, I can't do copyrighted characters, but you can have a very cute bear. Would you like a very cute bear? And I kind of went, okay, fair enough. You know, you win, ChatGPT. I'll take the bear. Yeah. So from what we've just seen, what are our test cases? Well, a valid ID should return a list of question objects. An unknown ID, whatever that is, that should return an empty list. An invalid ID like Fred, that should return an error code. So these are the things we want to test for. How do you write your tests in Ktor? Really straightforward. You just say test application brace brace. And inside there, you have a test instance of Ktor. So I like to think of this as being like a ship in a bottle. So you have the Ktor server running, but it's not running on top of Tomcat or Netty or anything like that. So it's going to be running really quickly. And into that, you can direct sample requests. So all the code inside the braces there, that's going to run inside a test environment. And then we can say application brace brace. Inside there, that's where you set up your service. So you install all the plugins that you would do in a production environment, or more likely a slight variation on the plugins that you would install in production for the purposes of testing. Talk about that in a minute. And then in the remaining code, we can just go out and invoke our endpoints and assert on the content that comes back. Let's write the test then for a valid user ID producing a list of questions. So we'll say configure serialization. We'll pass in the HTTP engine that we want to use. We'll use the built-in HTTP client to send a request to the server. We'll check that what comes back is a list of 9 questions, and we'll check the titles. I'm only checking the titles of 2 here because I ran out of space on the slide. So all good? And then let's say that we want to pass in an invalid ID with the name invalid. Well, then we should get an error code, and that works. And then finally, we want to pass in a long, which isn't a valid Stack Overflow ID. The technical way I approached this was to randomly type IDs into Stack Overflow until I found a long that wasn't a valid client ID. Yeah. So that was 9191919191. Yeah. So that should return an empty list of questions. So if you've been involved in QA in any way, shape, or form, you've probably been worrying the furniture there, clawing away, and you want to throw heavy objects at me, because that is not a valid test. You might be very, very generous and call that an integration test. But we're still going out, and we're using Stack Overflow. So at best, it was an integration test, not a unit test. What happens when I delete my account or I add a new question? What happens if we're trying to test without a network connection? What happens if we just have lots and lots of tests and we don't want to send all these requests over the network? It'll slow us down like a sea anchor. What we can do instead is we can mock all of this out. So I will send a request to the server, I will get back a response, I will store that in the file, and then I can modify the response to simplify the data, and then I can write a function that reads in that file and returns it as a byte read channel. So the advantage of doing that is I can then use it in this mock engine. So this is what you can use to mock out the HTTP client engine that the Ktor client uses. So I'm saying mock engine, brace, brace, and a request is coming in. I'm just going to check that the path contains 1, 2, 3, and as long as it's a GET request, well, then we'll respond with the sample data that we read from the file. Otherwise, we'll just return a 404. Having written this mock engine, I can then use it in the usual way. I can have my test just the same as before. I can say configure serialization just the same as before, but now I'm going out and passing in this mock engine. So in my test, whenever I go out there and send a request to fetch questions 1, 2, 3, it's going nowhere. It's the mock engine that's going to handle it. And I know that that will return a list of 3 questions with the titles that you see there. So I can do all of my testing as unit tests, having mocked out the connection to the server. Cool. And we're just getting started. There's lots of other ways that you can mock out requests from the HTTP client. See the documentation for details. We can use whatever testing frameworks we like CoTest and so on. There's an example of that at the booth. You can get the IDE to generate the tests for you, and the AI assistant will help write the code. So there's lots and lots of other things we can do. There's lots of support built into the IDE for Ktor for automatically generating tests based on routes and so on. So for any of the demos that I show you, we're just going to be scratching the surface. But that's shiny thing number 1. Shiny thing number 2 is Koin. Who likes dependency injection? Good. Who doesn't like dependency injection? Who is insufficiently caffeinated and half asleep? Yeah. Yeah. So for the next 5 to 10 minutes, we all like dependency injection. So the previous example highlighted an architectural problem, which is that we were creating the HTTP client engine, whichever one we wanted to use at a high level, and then we were passing it down through multiple layers. So for our little toy application, it's only an annoyance, but this is something that won't scale. This is the problem that dependency injection was designed to solve. This is the way the code is written at the minute. We're creating our instance of CIO, and then we're passing it into configure serialization, and then that's being passed into our Stack Exchange client, and that's finally being passed into our HTTP client. So there's this pattern of passing the object down through the layers. We want to avoid that if at all possible. So we can go out and we can use a dependency injection framework such as Koin. So what does Koin gives us? It gives us a Ktor plugin that we can include in our application, a nice DSL for declaring our dependencies, and a couple of different ways for injecting them. This is what you could end up with here. In your module function, in your setup function, you're saying install Koin. So we're installing the plugin, and then we're giving it a module that contains our dependencies, the things that we want to inject. In this case, we just want to inject a single instance of the CIO engine. We can put that in our module function at the top level, and then our Stack Exchange client, that just needs to extend Koin component, and then we can say there, engine by inject HTTP client engine, and the dependency will get passed in for us. So we no longer have this pattern of passing the dependency down through the layers. We can do the same thing in our tests. So in our test application here, we can say application install Koin and use a module that we've already created. So that's our integration test, also known as our very bad test. What we could do instead is we could declare the Koin module inline like this. So here we're defining the mock engine that we saw in the previous example, but it's all in one block of code there. But all good. So there are many different options in the way that we use Koin. Again, we're just scratching the surface. A Koin container can be scoped to an individual Ktor service. Koin components can live just for the scope of a single request. Modules in Ktor can load individual modules in Koin. And a Koin container has its own events that get published, and you can subscribe to those. Lots of extra functionality that you could use if you like. And even more interestingly, in the 2024 roadmap, the team said that, look, if you choose to use dependency injection, we're going to come up with a standard way of including a DI container. So from that perspective, it won't matter which container you use. There'll be a standard way of incorporating them into your Ktor services. But that's shiny, which hasn't arrived yet. That's shiny for the future. Right, so number 3, let's change the front end. Up until now, we've been using REST, but other options are available. Let's say you want to go out and use GraphQL. So here's a GraphQL console, and this is a query that we want to pass in. We want to say question and pass in a question ID and get back the titles of the questions. How would we do that? Hopefully you're getting the idea by now. We'll write a little helper method, and then we'll install the plugin. So we'll say install GraphQL and give the details of how we want it to work. So these are the packages here that we're going to say, use those to build the schema that the queries will be based on. And our queries are going to be types that we create. So this is them there. You can see that we have 2 types extending query. The first query is just going to be a hello query that returns a dummy value. The second one is going to be the one that you saw on the example on the previous slide. That's going to embed our Stack Exchange client. You're going to call questions and pass in a user ID. You'll get back a list of the questions. Finishing it off, we just need to go to our routing plugin and then have these 3 lines here. First says accept queries via post request. Second one includes the built-in client that you saw a minute ago, just for the purposes of the demo. And the final one is the instruction to build a schema based on the types in the package. Do all of that, and it works. We can go in and run our hello query and get that there. We can go in and run the question query and get back the titles of the questions. Super impressed. Yeah, I had no idea this would be so easy because I hadn't tried GraphQL with Ktor before I ran the demo. I thought it would take me at least a day. I had it done in a couple of hours. So really, really nice integration, really nice functionality. For more information, again, just scratching the surface, super good talk from last year's Kotlin Conf online at YouTube. That goes into the weeds. You know, that covers all the gory details of how it works. Right, so we changed the front end to use GraphQL. Let's change it again to use WebSockets. So let's say that this is going to be our prototype front end. We want to enter an ID and push the button and get the results streamed down to us. Particularly useless in the case of 9 questions, but let's say that there were 9,000 questions or 90,000 and they were being generated on the fly at the rate of 10 a second or something like that. Well, that would be the use case for using WebSockets. Just to say at the outset, who's afraid of WebSockets? If I could raise both feet, I would. Yes, a few people have been bitten by WebSockets before. WebSockets are a genuinely scary thing. So a lot of people, including myself, have spent hours looking at the screen till your forehead bleeds, trying to work out what the hell is going on. Ktor support for WebSockets is better than most other frameworks I'm familiar with. The reason for that, partially good engineering, for anybody in the Ktor team, yeah. Also, a matter of happenstance, a matter of good timing. Ktor is a relatively modern framework. All I mean by that, it was created relatively recently in the history of IT. Other frameworks, that they had mature support for HTTP requests and responses before WebSockets arrived. And it was a case of, what the hell is this? And we have to crowbar this into the architecture. But frameworks like Ktor, that they could be designed designed with WebSockets in mind. So this is how you would do it here. You've guessed it, you install a plugin, and there's no magic. So just because we're using WebSockets, that doesn't necessarily mean that we're sending JSON up and down, and we want the framework to unmarshal or marshal that JSON for us. So that's a choice that we have to make ourselves. So again, Ktor philosophy, no magic. If you don't install it, it's not going to be there. So you get used to anticipating that. Having done that, we can create our Stack Exchange client. We can have our endpoint, which is /questions, and we can wait to get the JSON for a user up the WebSocket connection. And then we can receive it. We can go out and fetch the questions as before, and then we can write them one at a time down the WebSocket connection to the client. And for the purposes of the demo, we'll delay a second, between each one. Cool. So this UI then goes out and works. See the repo for more detail. And make no apologies for the fact that this is a very simple HTML and JavaScript user interface. Tell you a secret I've worked out over 25 years in IT. Anytime you're using distributed systems, never use somebody's library at both ends of the connection, okay? So never use Ruby at both ends, or Kotlin at both ends, or C# at both ends, or Ktor at both ends, or HTTP for K, or any other thing, yeah? Because it's too easy for errors to get covered up, either accidentally or deliberately. So there might be an error in the way that something is being marshaled or unmarshaled, but because it's the same code at both ends, that error gets covered up. So whenever you're testing anything like this, make sure it's a completely different framework that you're using for the client. And ideally, good old plain HTML and JavaScript, just to validate what it is that you're doing. But wait, of course, there's an awful lot more to WebSockets. And actually, you've been using an awful lot more all the way through the conference. Who's been using the conference app? Hopefully everybody, yeah. Well then, you've been using Ktor and WebSockets because it was the Ktor team that built this application. And if you've used the web-hosted version, it's Kotlin WebAssembly as well. So there's a huge amount of shiny in the conference app, which is why we're very, very grateful that it's worked, yeah? But really good app. Next one, Kotlin Multiplatform. So what does that actually mean? Well, the Ktor client is fully multi-platform. You can use it with an Android app, an iOS app, a desktop app, and so on. And Ktor Server supports Kotlin Native, which means that you can build native versions of the services. Cool. So the first one, going to ignore for the purposes of this talk, because there's been other talks on the same theme. And also, whenever this went stable before Christmas, we went out with an awful lot of live streams and articles and so on going into the details. So Pamela and myself did the one at the top right there. And in that live stream, we showed this sample application here where it displays a list of countries with flags and capitals. And for each country, if you push in the button, you get the weather in the capital city. So that runs on Android, iOS, and the desktop, and it uses the HTTP client in each case. For more information then on the HTTP client and Kotlin Multiplatform, see those live streams, see this demo. Let's not do that then. Let's do something else instead. What we'll do is we'll take our application and we'll try to build it so that it runs natively. We can create a Kotlin native version of our project where if you look inside the build folder, you're going to get debug and release executables that you can go out and run. How's that going to be done? Well, in our Gradle build file, we're going to be targeting a particular platform and CPU, so that the Gradle build file is going to look completely different. This CIO implementation that we've been using of the HTTP engine, that only runs on the JVM, so we're going to need to use a different implementation instead. And then, so pass that in there, yep. And then whenever we're lifting out the data, we can't use the data frame library because the data frame doesn't work with Kotlin Native. So instead, we can just use low-level Kotlin X serialization to pull out the information that we need. So if we do that, we get our executable, bearing in mind, of course, it's a very small, simple thing, but it does start up very quickly. You can see the 0.003 there. So because it's a a native executable, bang, it's just, it's there, it's running. And it gives us the equivalent functionality. Cool. Moving on, we're almost there, just 2 left, I think. Open telemetry. Who works for a multinational that deploys a huge cloud of microservices into the cloud? Yeah, lots of people. So if you're going out and you're doing this, well then suddenly DevOps becomes really important. Or maybe is it DevSecOps or SecDevOps or DevFinSecOps or FinSecDevOps? They seem to be adding new things to this abbreviation all the time. But you have a team. And the job of that team is to make sure that all of your microservices are running correctly. So for them, observability is really, really important. For every microservice, they want to know, is this thing actually running? How well is it running? How much of various resources is it using? That kind of stuff. So OpenTelemetry is designed to offer a universal solution to that. There's a spec that you can use across platforms and industries. There's an API and SDK for all the major languages, and they provide a plugin that you can use with Ktor. What this lets you do is instrument your code. So you can take anything that you're doing and metrics related to that thing that you're doing, publish it as an event, and then that can get picked up and displayed in an administration console like Jaeger. So this is OpenTelemetry here. This is the kind of code that you would use. So we would install the plugin, and then we would want to go out and extract, capture some attributes about how our application is running. So let's say in this case, all we want to do is publish the user ID that we've received. Having done it and run the whole thing, again, see the repo for details, I can fire up Jaeger and I can go in and have a look, and I can see, yes, wait, yep. So we've connected here to our service. We're going to be receiving requests from that. And then, where are we? Hello. Yay. So we can see the different URLs that are coming in. There's our fetch questions user ID one. And if we scroll down through, we can get the details of the request, the URL, and so on. And in particular, we can see that the attribute we're capturing, and that's the user ID. So inside your Ktor service, you can use OpenTelemetry, you can extract the attributes that you need, you can publish these, and you can view them in a separate console. So if you're involved in DevOps, that's really, really useful. Then for our final bit of shiny, we'll kind of return to where we began, because the whole theme is no magic, that you have fine-grained control over everything. Let's say what we want to do is we want to retry requests until they succeed. So as I say, the no magic philosophy gives you fine-grained control. You can customize any aspect of how Ktor works. Let's look at retrying requests. So what we want to do is we'll have a little client, and whenever I push this button, it's going to send requests to the server, and I've rigged it so that only every 4th request will succeed. So if the request fails, we want to back off a bit and try again, and back off a bit and try again, and so on, until we finally have success. What's the server side going to look like? Same as before, but with this here. So call count mod 4 equals 0, go ahead and process the request, otherwise return an error. That's the trivial bit. What about on the client side? Well, we've got our HTTP client here, and we're going to install HTTP request retry. This will automatically configure support for retrying our requests. We can say the maximum number of retries is 5. We can configure how we want the delay to work. And for the purposes of the demo, we'll include another plugin. That's the HTTP send one. This will let us intercept outgoing requests just because we want to display the details in the user interface. So that's only required for the user interface and the purposes of the demo. I can go ahead and I can write my client application using Compose Multiplatform. I can run it on the desktop, and everything works just fine. Cool. Worth saying a little bit about how we created this in the first place. All the previous demos were created using the Ktor project generator. So if you want to create your own services, standalone services, that's the way to go. Let's say instead that what you want to do is you want to create a complete application. from soup to nuts, as we say, the whole shebang, the user interface and the server side. Well, then we can go here to the Kotlin Multiplatform wizard. And you can say, okay, I want an Android app or an iOS app, or in this case, I just want a desktop app. But I also want a Ktor server. So you'll get one project, a unified code base with multiple source sets. There'll be a source set for the server code. There'll be a source set for the Compose app. Inside there, if I was targeting different platforms, there'd be different platform-specific source sets as well. And then you have a shared source set where you can put your business logic and your model types and so on. But as I say, you get one project that will let you work with a complete application from soup to nuts. So if you were new to Kotlin before this conference and you've been inspired by all the talks and you want to go out and write a complete demo with all the moving parts that you've seen in the talks, well, this is a great way to get started. So that's it. We have seen an awful lot of shiny things. We've seen testing, DI with Koin, GraphQL, WebSockets, native execution, inclusion of instrumentation with OpenTelemetry, and we finished with the basics again, fine-grained control, taking charge of retries. What didn't we include? Well, we could have talked about database access with exposed. That would have been really good. Or other alternatives like Duke and JPA and so on. And we could have dug into how everything is based on top of coroutines. So there's the opportunity for concurrency everywhere. But again, other talks have covered this in details. There was a really, really good talk on exposed by Chantal. Really recommend you check that one out on YouTube. And another great one about Kotlin coroutines. And of course, there's huge amounts of resources out there about coroutines and how they work. Very important point also to stress that a lot of this work was not done by the Ktor team. So we've seen the Koin plugin, the GraphQL plugin, the OpenTelemetry plugin. This is the future of Ktor. So we really, really want there to be a vibrant ecosystem out there where every user of Ktor is a potential plugin contributor. And we've gone out and we've created a registry where you can enter the details of your plugins. If you're a third party or open source group and you've created your plugin, you can let us know about it here, and then it can get included in the project generator. So it can exist on the same level, with the same level of respect and so on, as all the other plugins that are already there. So that will hopefully help build up the community. So I was specifically asked to say, on behalf of the team, thanks so much for all the patrons who are currently using Ktor, everybody who's been providing feedback, and all the teams who've been providing all the plugins. It is very, very much appreciated. So what have we learned? Hopefully, Ktor is a good choice, but within a crowded marketplace. There are many other excellent products out there, okay? I want to get out of this room in one piece, okay? I'm heavily outnumbered here, yeah? So Ktor plays the long game. The team isn't interested in quick fixes or fad features. The focus is on this pipeline architecture and making sure everything works with everything else, and you can combine the plugins in whatever way you need to. And Ktor is continuing to grow features, community, resources. We're in the middle of rewriting the website at the moment. There's going to be a bunch of new documentation and tutorials and so on added. And the team is very committed to the community. So please, please, please let us know how we can help. Stop me in the corridors. Find us at the booth. That would have meant a lot more if this talk was yesterday. But you still have time to find us at the booth and ask questions and so on. And let us know how we can help. So that's Ktor. Thank you very much indeed. Please don't forget to vote. Thank you.